Cool. So this kind of hopefully gives you a little help with the curriculum going forward. I'm going to skip over MLE, which is kind of like in the middle of the section, and I'm going to talk about naive Bayes classification. To be quite honest, this is not going to be relevant to the project, naive Bayes classification. However, it's a really great introduction to machine learning going forward, because the classic example is talking about spam. So I'm going to go over a little bit, and I'm giving you that extra time because my dog kind of interrupted the show. So not really a show, but anyway, so we're going to go into Bayesian classifiers. All right. So basically you can use, I keep saying that and it cracks me up, but basically you can use Bayes' theorem to apply it towards classification. Basically you can use like how, what's it called? You're basically updating your posterior to determine if this is actually true. And so I'm going to kind of introduce classification. I think we'll actually talk about this a little bit more maybe next time too, kind of walk through a little bit more. But note that what we're going to do is essentially something called supervised learning. So supervised learning is a classification, and basically what it is you have many examples of something. Of like, you know, this is like, for example, the classic examples like, is it a dog or a cat from a picture, right? And having the computer determine, is it a dog or a cat? And so basically you have a bunch of pictures that are saying, oh, this one's a dog, this one's a cat, this one's a dog, this one's a cat. And you basically tell the computer, hey, learn from these examples, supervised, right? I'm saying, these are the correct answers, learn from this. And after the computer studies it, learns from it, trains from it, however you want to phrase that. And then you give it a new picture that it's never seen before. And you say, what picture is this? Is it a dog or a cat? And based on its basically prior information, right? Prior knowledge, prior information, you can then basically say, oh, the computer can help reason, oh, it's a dog or a cat. I'm doing this like very like vaguely, like there's obviously a lot more to the algorithm itself, but that's the idea, is that you give it some already pre-labeled data and you say, okay, this is what it looks like, figure out stuff that we haven't labeled yet, okay? So again, like the classic example, is it a dog or a cat, right? So clearly a cat, as we can all clearly see and everything like that. And you basically feed it to the computer and say, all right, like, what is this gonna be? Now, there's a difference in this, is that I kind of noted it right here, is your categorizing is not the same thing as linear regression. It can be related, but your linear regression kind of is telling like the degree of something, right? Like for example, the housing prices and how much is this house predicted to be. Our categorizing goes in a very different direction, saying basically like a binary or multiple class, but essentially it's saying, is it this or that? Okay, so you can think of a dog or cat. It's not saying how doggy is this picture, it's just saying, is this a dog? Okay, and we'll talk about spam versus like ham, like a spam email. Like it's not saying how spammy is this email, it's just saying, is it spam or not? Usually when we say like, is it more spammy? Usually say, is it a higher probability that it is spam? That's what we mean by more spammy. But it's not actually classifying of saying, oh, this is more spammy than others. It's just saying it is spam, and that's all it really cares about. Okay, does that make that clear, that distinction? Cool, all right, so, so spam, right? So everyone hates spam. Well, I mean, I like eating spam, but like spam email is like awful, right? Like, and I don't know about you guys, like if you've been using email for a while, like I'm saying like the past like 10, 15 years, you've probably noticed spam has gotten pretty good. Like I almost get like almost no spam in my email. I don't know about you guys, but like, you know, spam classifier seems pretty good, like detecting when it's spam. And a big step in this was actually naive Bayes, is using naive Bayes to basically detect spam. So the way this kind of works is it's something called, again, like naive Bayes, which is basically using Bayes' theorem with a naive assumption, which we'll talk about why it's not that bad to say it's naive, okay? And basically all you gotta do for a naive Bayes is say, you look at a bunch of emails, for example, say, look at what's spam and not spam, okay? You label, say, ah, this is spam, this is not spam, or we call it ham. So ham, spam, you separate the emails out. Then you identify the words. So you choose certain words. You can either be based on what you believe would be relevant. You might be doing a data analysis of saying what are common words are used in here. Basically words that would suggest the classification. So if you see, for example, a lot of words that are only used in spam, that would be a really good word to use to classify whether it's spam or not, okay? And you might do it not just with one word, but might be multiple words, okay? So like, for example, if the email uses the word cash in, you know, now and like, you know, help or something like that, maybe like it's like, oh, it's probably a spam thing, you know, like that's just what we see a lot of, okay? And so what you do then is you determine the probability that the word occurs in each classification. Basically say, how often does this word actually used in spam? How often is this word actually used in ham, right? And you basically say those two parts. And then you basically say, all right, cool, I got this new information, and you apply it to some new emails that you've never seen before, whether it's spam or not. And that's essentially what naive Bayes is doing. That's kind of like a very quick, like, oh, that's what we do, okay? So you can see it's not too bad, right? And so I'm gonna answer this question for you guys because I know I'm kind of running low on time. So why is this awesome? Well, one is that we can keep updating our belief on the email we detect. So if we get more and more spam, when we say after the first bit of spam, we're like, oh, cache is a really, detector of spam. And then if we get more and more emails, we're like, oh, wait, no, cache is actually like 50-50 spam or not. It's like, oh, maybe we need to update our belief then of saying that the word cache actually signifies spam. This can also be true as time goes on. Maybe spam changes in the way it's phrased, which you probably know, like, going from all the way from the 90s to now, spam has gotten a little different in how they classify or how they phrase things and stuff like that. So there are different ways to update it. So we can keep updating our belief. It's relatively simple. You just saw me write it in 4 lines, essentially, of what is going in. The last line is more of a joke than anything. So you can kind of see, like, it's not too hard to, like, get the idea of what this is doing. And we can expand this to multiple words. So we don't have to rely on just, like, one aspect. We can do multiple aspects. So there are other more advanced things, but naive Bayes is kind of a good one to go to for machine learning. It's kind of like the immediate, like, hey, let's try naive Bayes and see how well it works. And it actually does a pretty decent job, okay? Now, there is one part of our actual naive Bayes before we do it, is the naive assumption, which is why it's called naive Bayes. So naive basically saying, like, oh, like, you really shouldn't do this kind of thing, like naively, like you're gonna assume this thing, but it turns out it's not that bad. So basically it's that, and you'll see this notation right here, the curriculum shows like P, the probability of A comma B, which should be interpreted as the probability of A and B. So A and B happen together. We can say, well, if they're independent, then we can say the probability of A, or the probability of A and B is just equal to the probability of A times the probability of B. Note, however, that's not always true. For example, if the spam email uses the word cash, it might also use the word money, right? And those aren't actually independent. But for the most part, it works relatively well, and there's enough frequency that this happens that it's a pretty good assumption. So in practice, we usually can make this assumption, even though it's probably not true. It's usually true enough for us to actually assume this, okay? So that's kind of like the naive assumption to kind of like remember that this can happen, but you're just gonna proceed forward anyway, okay? So now it's actually performing this part. And I'm gonna go through this relatively quickly. Maybe next time we'll actually show like an example of this. There are labs in the curriculum that kind of show you an example of naive Bayes, but I just wanna show you like the basic of like what this looks like. So the first thing is the formula. So I'm gonna start off with one word, cache, right? And this right here is our base formula, the probability of spam such that it's given the word cache. So you get an email and you say, hey, it has the word cache in it. Is it spam or is it ham? Okay. And so this is just going to be equal to the probability of cache, having the word cache such that it has the words, or such that it's spam. And then say it's the probability of actually having spam divided by the probability of using cache just in general, whether it's like cache for spam or cache for ham. Okay. Everyone follow me so far? And there's a lot of words just being thrown around all over the place, but hopefully this is kind of similar to what we've seen before. Okay, so quick knowledge check. I'm gonna kind of go through this a little quicker than normal. All right, how do we find probability of cache? Okay, well, you really need to figure out what the probability of the cache is just using that word. We just say, how frequently does this word happen? And this is where the curriculum will actually go through like how to split this up and use, we talked about this actually in web scraping a little bit of saying like, how you could maybe like, back up the words and everything like this. But here we're just gonna define probability of cache is just gonna be 0.02. So, oops, I just realized I didn't restart this. Let me go. Cool. So we don't get any funkiness. So say, okay, say 2% of all words are the words cache, okay? So I just gave it a probability, but in reality, you would actually measure this frequency, okay? What about the probability of spam? Well, we have a bunch of data. Some is spam, some is ham. We basically say, okay, how many of these things are actually spam? And we say, okay, we count up all the emails, and we find out 10% of all emails are spam. It's like, okay, cool. That's our probability of spam. So you can see here, we're already starting to get like this guy right here. We got the probability of cache. The next thing we need is just the probability of cache such that spam, right? So we need to say, what is the probability of cache, the word cache happening, given that this email is spam, okay? And this one's a little harder, I think, to kind of get your head around. And so basically it's just saying how often the word cache is used only for those that are spam. So we only look at the spam ones, we look at the cache one. When we count the frequency across all spam emails. The curriculum mentions a little bit, it's like, hey, but there's an issue here. Does anyone can see what the issue might be with this, using this word? Like why this might be a bad idea, or at least might give you some trouble. It's a subtle one. I think I wouldn't guess it right away. So one issue is that if the word cache never happens in spam, right? That could be just because we've never seen an email from our supervised data set, right? So our data that we already have, maybe just we never came across a spam email that has the word cache in it. So the problem is, remember how we said about the Bayesian trap? If you set the probability to 0, right? So if cache never shows up, we'd say, oh, this is equal to 0. This can give us a lot of trouble because obviously, you know, we don't want to set it to 0 because then our posterior will always be 0 and it'll always classify as ham. So what they do on the curriculum, they talk about a strategy using the Laplacian, basically using Laplacian to adjust this to say, well, we basically get it always a small probability, never no probability. And there's some ways you could do this. You could always define it. For example, the naive way would be like, oh, just set it to 0.01 or something like that. But there's a little more subtle ways we can do that. So the curriculum times very quickly says, or we can just define it this way. So just know that there's a little subtlety going on here. But assuming that we do have the word in here, we count all the words in there, like, cool, 12%, right? I just made this number up, but the idea is you would count this out, okay? So we have all our parts now. We have probability of cache, probability of spam, probability of cache. Cool. So then we just have to calculate that, and all we have to say is like, all right, given all these parts, we put it all together, and we see the probability, if the email has the word cache in it, there is a 60% chance it's in, the email is spam. And this is where, you know, this is just using one word. So like this is where, you know, 60%, depending on your threshold, you might say, well, there's 60% chance it's spam, but it might be an important email. Go ahead, let it through. Or if you're like really aggressive with your spam filter, you might say 60%, nope, throw it out, you know? So if there's a high enough chance, like it's better than 50-50, you just throw it out. It just all depends on what you prefer and what is important, right? So that's kind of how you would calculate this part. Any questions on like how I walk through this part and how you essentially would get these parts? Thumbs up if it sounds good right now. Any questions on this? All right, cool. And again, I kind of didn't show you how you would calculate this. The curriculum shows a good job of like using this like with NLP tools, like word tokenize and stuff like that. But the idea is the same. You basically figure out the probabilities, and once you have the probabilities, boom, stick it in and you're done, right? So you don't have to like worry about like figuring out each individual part. It's relatively simple, okay? So one thing you can do, I just wrote a real quick thing here, is you can use multiple words. So if you have multiple words, like buy and cache, you would do the same thing, but because they're independent by the naive assumption, we can essentially split these off. So you can see the probability of spam, probability of spam such that buy and cache. We would split this up into probability of spam such that buy times the probability of spam such that cache, and you would just multiply those two parts together. And so then you just basically have it combined together, and you just have a lot more probabilities, but you can calculate it versus how the probability of buy and cache, if they weren't independent, you'd have to think about like, well, what's the probability of it interacting and stuff like that, and it'd be a huge headache. So the naive assumption makes it really easy for us to just calculate straight up. Okay. All right, and that kind of ends kind of like the thing for naive Bayes and Bayes theorem and everything like that. So next time is section 24. We'll talk about resampling in Monte Carlo, but we'll also go into MLE, maybe a little bit. If anyone came in a little bit, I know a couple people kind of came in a little bit later, so I don't know if anyone caught this. My suggestion for section 23 is kind of skip over MLE, at least for right now. You know, Phyllis, obviously, like, you know, you're welcome to join us over there. That, at least for my cohort, I'm suggesting to skip over it so we can talk about it in module 4, maybe next time, but it's not super important for us to be able to do stuff right now. So I'm saying it's kind of like on the lower threshold of what's important. And honestly, that section in 23 is kind of hard to understand, if that makes sense. It's a lot of mathematics and a lot of, I get the feeling when most people go through it, they're always like, I get each individual part mathematically, but I don't understand what the end said. So we're gonna walk through that together a little more closely. But I'm gonna kind of glaze over it right now because I think it's not super relevant for what we're doing, at least especially for this module project coming up. Sound good? Cool. All right. Well, everyone, I guess I can go and stop recording unless there's any other questions. Cool.